All right, this week I am asking you to compute a variable, to transform a variable, and then to do an independent samples t-test and a paired samples t-test. So I'm going to walk you through those steps with this enrollment data that you will also have for homework. So the first thing we're going to do is we're going to create, let me go to variable view. We have English 1 and English 2, and I want to make a average of those two. So in order to do that, I go to transform, I go to compute variable. I'm going to call this English av, and in order to do that, what do I have to do to take an average? I add them and divide by 2. So I'm going to use this parentheses here. This is like a calculator. Puts my cursor in the middle of the parentheses. I come down here and I click English 1. I bring it over. I tell the computer to add English 2. Bring it over. Come outside the parentheses. Use this / as my divisor. And divide by 2. Then I'm going to say OK. All right, this is output I had from before. Let me toss that. So what the computer does is it brings us down here and it puts the new variable here. If I wanted to grab it, move it, and put it next to English 1 and 2, and now I have English av, I can do that as well. Okay, so that's how you transform. You go transform, compute, and then you can go into this calculator and do any number of calculations. All right, so the next thing I want to do is I want to, I believe I asked you to make smoking not smoking, but I want to look at, I'm going to show you on a different variable. This variable, how commute, there's quite a bit of missing data, but that's okay. If you come to the variable the value label, you can see that number 1 is walk, number 2 is bicycle, number 3 is car, and number 4 is public transport. All right, and I also have commute time. It's kind of hard to see there, but I want to see the difference in commute time by walking or auto. But I have 4 categories, and I can only do it with 2 right now. So I'm going to change walk and bicycle to just on foot or human transport, and then 3 and 4 to auto. So auto, not auto. All right, so how do I do that? I go into transform again. If you recode into same variable, you might mess up and then you've lost your original data. So I always go to recode into different variable. And this is a little bit more complex, but I'm going to go into, go into how commute. I'm going to bring it over here, and I have to give it a new name. So I'm going to say how com 2. All right, it doesn't matter what you name it. And then you have to hit change so that it has given it this new label. So this old and new values. So let's look again, right? If we had 1 was walk, so I want to keep 1 as 1. So my old value here, old value was 1. My new value is 1. I have to do that even though it's already labeled in the variable because I'm doing a new variable. If I didn't make this, it would leave the ones out. So I say add. Now 2 is bicycle, but we're going to say that's also a 1 because we're making 4 categories just into 2. So now we have walking and bicycle just as human, and then we have 3. We're going to call that 2. And then we have 4. We're also going to call that 2. So I'm taking 1 and 2 and calling them both 1, and 3 and 4 and calling them both 2. I'm going to say continue, OK. It's given me the output that I've done that. Let's go back to the data. And here it is at the bottom. Now we have 2 variables, and so we need to label them. So 1 is no car, and 2 is car, or whatever you want to call it. It doesn't matter. But the dichotomous variable now is you're either human motored by walking or bicycling, or you're in a bus or you're in a car. Okay, so now The next thing we want to do is there a significant difference in commute time by mode of transportation? So I'm going to go to Analyze. I'm going to go to Compare Means. I'm going to come down and go to Independent Samples t-test. Now my outcome variable, my test variable, my dependent variable, it's got a bunch of different names, but it's my dependent variable is commute time. And my grouping variable, my independent variable, is howcom2. Now look, we've got these little question marks. What does that mean? I go to define groups, and I have to tell it that in my code, group 1 was labeled 1, and group 2 is labeled 2. But I could have said 0 and 1, so it just needs to know what it's testing. We don't even need to do these are auto-populated, so we're just going to say OK, and we look at our output. All right, so 41 people out of this data set don't travel by car, and 206 do travel by car. So that is a very lopsided sample size, and because of that, we would say it's kind of suspect. Our findings, you know, if we were to write this up in a publication, they would say, you know, you have very unequal sample sizes. Go collect more data. But for now, this is just for a learning experience. So the mean in minutes is it takes these guys half an hour by car, and these guys about 13 minutes by car, by foot. Most likely, these are the guys who live on campus, because I think this is enrollment data set from England, the university in England. So what do? So that's our output, our descriptive statistics. And then we have to come down here and look at Levine's test for equality of variances, because one of our assumptions is that we have equal variances, that there's not a huge difference between these two groups. And we don't want to reject the null on that, because the null hypothesis is that there is no difference. And look, we do reject the null hypothesis. There is a difference. This is a big disparity, and so therefore we reject the null, but we're not dead in the water. We're just going to come down to the bottom row where it says equal variances not assumed. And so we can see that that's a very large t statistic. Our degrees of freedom, they do this adjustment, right? And so we have different degrees of freedom. We would report the bottom row. Our significance is highly significant. There is a significant difference in the amount of time it takes for people in cars to get to school as opposed to people on foot or on bicycle. Calculator. All right, one more thing I want to show you before we move on to the next thing. I have been asking you guys to assess normality by looking at graphs, and I've gotten, some of you have been frustrated because you can't really tell, and so I want to show you another way to do it. We can go to Descriptive Statistics, come down to Explore, let me reset. Then let's look at commute time and bring it over here to the dependent list. I could look at it and do it by a factor, like by how they commute, but I don't even need to do that. I'm just going to come over here and I'm going to say plots. I'm going to uncheck stem and leaf, and I'm going to check normality plots with tests and say continue and say OK. And what that gives me is these detrended, or the QQ plots that we've done before, and box plots. We don't care about that. What I want to look at is this Shapiro-Wilks test, or the Kolmogorov-Smirnov, but we usually look at Shapiro-Wilks. This works the same way as Levine's test. If it's significant, it's not normal. If it is not significant, it's normal. So we can see also from this QQ plot that it's not normal. And we can also see that it's highly significant, so it is not normal. So that we kind of screw up one of our assumptions, and therefore I would say that the results of this test are not conclusive. Even though we have a significance, our assumptions have been violated. Okay, so let's try one more. First thing I want to do is I want to check the normality. So I'm going to go over here and I'm going to say Explore. And I'm looking at English 1. I've already moved it over. I come to Plots. The stem and leaf was checked. I uncheck it. And I click Normality Plots with Test. I just want to see is English 1 normally distributed. So I'm going to say OK. and I look over here, and I see that the Shapiro-Wilks test is not significant, and therefore we can say it's normal. We look at the QQ plot, and it hugs the line. There's a little bit of weirdness going on down here, but the test is not significant, so we're going to say it's not significant. All right, and then there's our box plot. We didn't ask for that, but it gives it to us. Well, it gives us just the normality plots with the test, and we're interested in the test. All right, so let's keep going. Let's try comparing means, independent samples t-test, and I've done it by gender. Let me reset it because I think I had that wrong. We are going English 1 by gender, and I have gender labeled as 0 for male and 1 for female. So I say okay, or continue, and okay. And again, we have a significant Levine's test, so we violated that homogeneity of variances for this test. So we come down to the bottom row, and we look and we see there is no significant difference between males and females on their English 1 test. We can see there's about 20 some odd more students in the female category, but they're almost exactly the same. And I'm not sure why the Levine's test is not significant, but that's how it unfolded, so that's what we would report. We would say violated the Levine's test, and then you just report. I don't really care so much, I just want you to report out all of the statistics that I've asked for in the homework. Okay, let me pause it. Okay, so I have pulled up the Cohen's D calculator. All right, it gives us all of these Cohen's, glasses, delta, hedges, G. And so I have it pulled up, and I'm going to enter the data here. So we have the mean is 82.73. Standard deviation is 8.09. We'll just go with that. Sample size is 188. Group 2, we have the mean is 82.75. Standard deviation is 5.5. Just round up. And then 213, I hit calculate, scroll down, and here is our Cohen's D, 0.002 or 003, so negligible, almost not even there. All right, so let's go back. One more test we're going to do analyze, compare means, and we're going to do paired samples t-test. And let's see, is there a difference between the English 1 test and the English 2 test? And that's all we have to do. We just move over English 1, let me reset it and show it to you again. We have English 1, move it over, English 2, move it over. Don't even have to click these, just say okay. Now, we have our descriptive statistics here. The sample sizes are the same because it's everybody taking the first one and everybody who took the second one. If somebody's missing one of the other tests, it throws them out. And then we get a correlation coefficient, but we don't really care about that right now. That's just SPSS has to do that to create the confidence intervals, and they give us that output, but we're not concerned with that yet. So what do? We look here, we have the mean, difference, so this one minus this one is this, standard deviation, standard error of the mean, lower and upper confidence intervals. It does span 0, so we know that we are not significant if we look down here. We're not going to be significant. Degrees of freedom is taken 1 away because we're just testing that one parameter, the mean difference, not 2 groups. It's really just 1 group, right? And our t-statistic is here. And then I could go back to that calculator that I used before and plug it in and get the hedges G there, or use the one that's in the PowerPoint. And that is pretty much all you need to do.